What's up everyone, my name is William and today we're going to be going over the filter effects included in Logic Pro. So first of all, I've opened up a new session here and I've set up a couple of tracks, one for each of the filter effects we're going to be covering and one without any effects on it. We're going to be using the Carla Lyric 02 vocal sample. I just found it in Apple Loops. If you go to Apple Loops, search for vocals and you scroll down, you can find the Carla Lyric 02 audio sample that I'm using if you want to use the same. Jumping right into it, let's just first listen to what this vocal sample sounds like without any effects on it.
Get up, get up, get up, get up, get up, get up. Oh, get up.
So that's what our vocal sample sounds like with anything on it. Jumping right into our first filter that we're going to be covering is the auto filter. The auto filter is a very versatile filter effect that can be, used when you're getting more in depth with creative sound design and things like that. It's definitely, in my opinion, one of my favorite filter effects that is included in Logic. So looking at it, it's broken down into 5 sections. We have the filter section, the distortion section, our envelope and LFO modulation sections, and our output parameters. I'm just going to recall default just so we make sure we're on the same page. So going over some of these parameters, starting with the filter section, it's just a normal filter, something that we should be familiar with. We adjust the cutoff here. A lower percentage is a lower cutoff, a higher percentage is a higher cutoff, as well as resonance. This, boosts the frequencies around where the cutoff is located, and we can determine how much it's boosting by changing this percentage here. 0% is no boost, 100% is the maximum boost we can do. Next, underneath it, we have quite a few buttons here. These are just different types of filters that we can choose from. As you can see, we get like a high pass, we have low pass, and we also have 4-pole low pass features over here, as well as some other ones. So that's what that area is. Moving on, we have a couple of sliders here. We have this fatness slider. First of all, this determines the boost amount in the low frequency content of our signal. So we can boost the low frequency content by turning up the fatness. Next, we have a spread, which is this. This is just like a stereo spread, a stereo spreader to artificially spread the stereo image. Next, we have our envelope and LFO sliders. These sliders determine how much the envelope and LFO is modulating our filter. So like right now, for example, our envelope is modulating 50% and our LFO is not modulating at all. So we can change these values to determine how much modulation is occurring with these two sections. Moving on to these two sections though, starting with the envelope section. The envelope, it's just used to create different modulations with the filter effect. The envelope has a basic attack, decay, sustain, release, and then we also get this threshold here that determines when our envelope is going to begin modulating our signal, and also this circle right here is actually a light that will light up to kind of let us know when it's starting to modulate. It'll light up green, as it's being modulated. And then the last thing about the envelope is we have this dynamic knob. This just changes the modulation with how the envelope, modulates our signal. It just changes how it does that. So let's just listen to what this sounds like just with the filter. It's just 50%, 4-pole, 24 dB, low pass filter. Nothing else on it right now. The envelope isn't modulating, the LFO isn't modulating, nothing else is being manipulated. So let's just listen to what it sounds like with just the filter. So you could hear that it sounded very low pass. And also, if you didn't notice, this light actually lit up dependent on this threshold. So let me just play it again real quick. So the light changes dependent on whether or not the signal is crossing this threshold that we set here. And so now let's listen to what it sounds like. I'm going to set this back to a 20 dB envelope, or 20 dB threshold, excuse me. Now let's see what it sounds like when this is being 100% modulated by the envelope. I'm going to increase the attack a little bit. Let's just hear what that sounds like.
Get up, get up, get up, get up, get up, get up. Oh.
So now, as you can hear, as it crosses the threshold, it uses this envelope to modulate. So it starts opening the filter and then it closes it again, depending on how this envelope is set. So now focusing on the LFO modulation and how that works, we get a rate knob that we can either sync or not sync to our BPM. And if it's synced to our BPM, we can determine the phase of our channels with the LFO, as well as our stereo phase right here. And then, of course, we can select the type of waveform our LFO is. I'm just going to stick with the triangle waveform, as well as if we are using the pulse wave, we can determine the width of our pulse wave here. So some pretty basic LFO controls. So let's listen to what this LFO sounds like. I'm going to set it to fourth notes. Let's listen to what it sounds like when the LFO is fully modulating the auto filter.
Get up, get up, get up. Oh.
So you could hear the LFO modulating the cutoff of the filter, and then this light is again kind of when it's modulating. So so when it's lit up green, it means it's playing. When it's dark, it's not going to be playing, because dependent on the rate of the LFO. So if we're set it to something like 1/8, you'll see this will blink faster. So that's some very cool things that we can do with that. Moving on, we next have the distortion section of our auto filter. The distortion section is pretty basic. We get 3 types of distortion that we can choose from. These are just different modes, give us different sounds for our distortion. And then we also determine how much distortion we want to happen before our filter and after our filter. So you got to keep in mind that if you add distortion before it goes through the filter, it's not going to, you're not going to get those high frequencies still, because it's going to be cut off by the low pass filter that we have set right now. Whereas, if we use the post filter distortion, we'll hear those high frequencies because it's not being filtered out at all. So that's just something to keep in mind. This is just pre-filter, post-filter. You can determine how much you want to distort based on that, and then each of these has the same 3 different modes that we can change individually. Last but not least, we have the output parameters. First of all, we have this main output slider here, which we can just reduce the volume of our output by adjusting this. And then we also have this dry signal slider, which this adds a certain percentage of the completely dry signal back into our sound. Unlike regular or a lot of the other dry wet signal mixer signals that we've seen, this doesn't mix the dry with the wet. It actually just adds dry back into the signal. So you're getting the full wet signal and 5.560% of the dry signal is also being added to that. So that's just something to keep in mind. So if you start adding higher values of this, you're definitely going to need to reduce your main output so you don't have the output set too loud. But that is about it for the auto filter. Definitely very versatile. Check out some of the presets. There's quite a few here. One of my favorite filter effects in Logic. Moving on next to the EVOC 20 filter bank. So the EVOC 20 filter bank consists of two filter banks that the signal passes through in parallel. This effect can be broken down into three sections. We have our actual formant filter banks section here. We have our modulation section down here, and we have our output parameters on the right side over here. So jumping right into it, where most of the magic happens in this is in the formant filter bands. So we have these two banks here that the signal passes through in parallel. We can adjust how many bands that there are in each of these banks, and we can control the banks or the bands of each bank individually. We have all of these options, so you have a lot of flexibility with this filter bank. You also, at the top here, you can adjust where the lowest and highest band are respectively on the spectrum. Right now we have it set so the lowest band is at 80 hertz and the highest band is at 8,000 hertz. We can move these sliders to adjust the min and maximum like so. I'm just going to set this back to 80. We also have this formant shift knob here, which shifts the formants of all the bands of both banks up or down dependent on how much we adjust that. In addition to determining the bands, we also can determine the slope of each band. We have a 1 and a 2, which obviously this isn't very clear as to what that means, but 1 is 6 decibels per octave for the bands, and 2 is 12 decibels per octave for each band. So that's just something to keep in mind. 1 will give you a smoother sound, where 2, will give you a much more sharp cutoff. Next we have these two buttons. We have the highest and lowest, which this just determines how the highest and lowest bands will act. So if you want the lowest band to act like a low pass, you can do so like this, or if you want it to be a band pass, vice versa for the highest band, except it's high pass or band pass. I'm going to set them both to band pass, just leave it like the default. Next, we can control the resonance of our bands. This controls all the bands, to change the tonal quality of our sound. And the last few things about this, filter bank section is we also can control the boost or cut of our banks individually. So if we want to have bank A louder, we can do so, or if we want bank B louder, we can do that there. The very last thing of this, filter bank section is we get the fade between which filter bank we're hearing. At 50%, we're hearing both of them evenly. At the top, we're hearing just the bank A, and at the very bottom we're hearing just bank B. You can see with the colors that correspond, blue is bank A, green is bank B. So a lot to cover there. Pretty in-depth stuff. Definitely mess with the presets if you're not 100% familiar with how this works. But moving on to the modulation section, we get two LFOs for our modulation section. Pretty straightforward. You should be able to, just by looking at this, understand what most of this means. We get, first of all, in the center, we can choose the waveform of each LFO independently. The left buttons control our left LFO, and the right buttons control our right LFO. We also get rate knobs for each of these, and we can sync them or have a free value dependent on where we're adjusting this on the on the spectrum, on the left side of this knob we get synced values, whereas on the right side of these knobs we get a free hertz value. It's not synced to the BPM or anything. Whereas in the center there's going to be no LFO. Next, we have the intensity slider for both of these. This LFO on the left controls the formant shift knob over here, so we can control the intensity of how much the LFO is controlling our formant shift, and then on the right we're controlling our bank fade right here, our fade AB. So this LFO is controlling that fade. We can determine the intensity of that with this slider. Pretty straightforward stuff, just determining how we want the LFO set and then determining the intensity. LFO 1 over here, or the LFO shift, controls our formant shift. LFO 2 or LFO fade controls our fades between bank A and B. Moving on to the last section of the EVOC 20 filter bank is we have the output parameters. Most of this you should be pretty familiar with. First of all, we have this overdrive button. This just adds an overdrive effect to our sound. If you wanted to add that at the end there, you can just enable that by clicking it. We then, of course, have our output level. By default, on our factory default setting, it's at 7 dB, but of course we can turn that down or up dependent on what we want to do. We have a lot of flexibility there. Next is the stereo mode. This just determines how the signal is being processed. This is stereo to stereo, and this is mono to stereo. Typically it's on stereo to stereo, and that's typically honestly what you want to just leave it on. Unless you are dealing with mono signals. Next is the stereo width, which just determines the width of our output signal. At 0, it's a mono signal. At full, it is just a full stereo image, and we get values in between to adjust that. But that is about it for the EVOC 20. I know that was a lot to cover. Let's pick the formant morph preset and listen to what it actually does to our sample.
Get up, get up, get up, get up, get up, get up. Oh.
Now again, just so we can get a refresher, this is what it sounds like without our filter on.
Get up, get up, get up, get up, get up, get up. Oh.
So definitely some cool effects we can get with the EVOC 20 there. Moving on to the EVOC 20 track oscillator. This is the next thing we're going to be covering. So the EVOC 20 track oscillator is simply a vocoder filter effect. It can be broken down into a couple different sections here, but let's just jump right into it. First, starting off with this top left section, we have the analysis section. We have the attack and release knobs, which determines how fast and slow the envelope follows based on when the sample is increasing or decreasing in volume. Next, we also have this freeze button, which, with it enabled, it saves the current analysis of the sound spectrum to be used throughout the entire clip, the entire track. Next, we have the actual analysis input. This just, tells the EVOC 20 where to look for the input. By default, we want to have this at track. That just means it's listening to whatever's on the track. Or we could also do sidechain and set a sidechain input here if we wanted to do that. Next, we have our bands, slider here that we can determine, how many bands we have in this vocoder. Also, I didn't mention, but I'm actually using the basic 02 preset. It's in channel resynthesis, basic 02, if you want to follow along. Moving on to the actual, oscillator portion of the vocoder, we have this section right here is the oscillator portion. First of all, we have the synthesis input, which determines what how the EVOC 20 is processing the synthesis, whether it's using the track, the sidechain, or the oscillator. I'm going to be using the oscillator. And then we have some settings here. We have the frequency modulation ratio of our oscillator, and we also have the FM intensity knobs right here, which changes the tonal quality of our sound. Then we have some tuning adjustments here. We have this course, which we can change the tuning of our oscillator in semitones, and this is a fine tuning, so we can adjust it in cents. So we get more options there. At the bottom, we also have this pitch quantize area, which it kind of allows the oscillator to sync to different notes on our scale. We have a simple strength slider to determine how intense the correction is in that pitch, and this glide slider that determines how long it takes to get to that correct pitch. And over on the right side of this pitch correction area, we have the scale that we can adjust here. We can select different presets, or we can select custom scales by just clicking on the notes and whatnot. The last thing in this section is the max track, which this just determines the maximum frequency that it's going to be using to detect the different pitches to get a correct pitch. This is important to pay attention to because if you have a lot more frequencies in there, it can tend to get harder for the EVOC 20 to detect which pitch is the correct pitch. Moving on to this center section here, we kind of get a visual representation of our bands. So just like the EVOC 20 filter bank, we also have this meter right here that determines the lowest and highest range. It determines our range that our bands are affecting. We also get the lowest and highest buttons here that determines how the bands are acting. Whether it's acting as low pass and high passes or band passes. We can just click and toggle that. Underneath this, we have a couple different options to change the tonal quality of our sound. We have a formant stretch knob, which stretches or shrinks the formant of our sound. We have a formant shift that can shift it, positive or negative values. And we also have resonance that controls some, it gives us some more tonal control over our sound. Next we have this UV detection mode area, this UV detection, which this stands for unvoiced and voiced detection. When you have someone speaking, unvoiced and voiced tend to be in the sample, the two different types of vocal, and this just allows us to detect the differences between those and allows it to work better as it's acting as a vocoder. So we have this just detection mode. These are just different modes in how it's actually detecting these unvoiced and voiced signals. And then we also get sensitivity knob, which determines how sensitive it is to detecting those signals. And then this level knob, which increases or decreases the unvoiced phrases in the signal. Moving on down here, we have our modulation section. We have, we can adjust the waves, the wave type of our LFOs. And then we also have our LFO, just one LFO is all we have. But we can use this LFO to control either the formant shift or the pitch shift. So we can, use these knobs or these sliders, to determine the intensity of those. The bottom is the pitch value. The top is the shift, the formant shift value. And then also on the right, we have the rate knob. On the left, we have our synced values, and on the right, we have our hertz or our free values when looking at this rate knob. The very last section is the output parameters, of course. At the top, we have the signal, which determines what signal we're listening to, the vocoder signal, the synth signal, or the analysis signal. So we can change those if we're, wanting to hear different things. We can change what's being listened to there. We also have this volume control, just a simple level control. We also have the stereo mode. Whether or not the input is a mono or stereo would determine how we're using that. And then we also have the stereo width, which controls our width over our stereo spectrum. That is about it for the EVOC 20 track oscillator, though. A lot to cover, I understand. But let's just listen to what this is actually doing to our signal. So let's listen without this effect. Let's listen to the sample without this effect first.
Get up, get up, get up, get up, get up, get up. Oh.
Now, listening to this sample with this EVOC 20 track oscillator. So as you could hear, it was quite a difference in the sound there, using that. So you can get some really weird effects. Definitely check out some of those presets and things like that. But the next effect we're going to be covering is the fuzz wah. So the fuzz wah effect simulates the auto wah effect that is very popular. Before we jump into any of these parameters, the first thing I'm going to point out is, it's broken down into 3 sections. We have the actual auto wah parameters. We have a compressor, and we can set the ratio of that. And we also have a fuzz distortion. One thing about this effect that's very cool is we can actually drag and drop to change the order of these any way we please. So if we want the compressor to be before the fuzz distortion and then the auto wah, etc., we can do that just by clicking and dragging these around. And of course, our signal flow goes from left to right. So that's just something to keep in mind before we get into all the different parameters. So first, looking at the auto wah, obviously the main function of this effect. We can set the type of wah effect we have. I'm using the bass automatic 02 preset as an example. So we're going to be using the resonant low pass mode for this. Next we have, quite a few different knobs and things. So first, the relative Q knob. This knob actually, determines the Q of the auto wah. Pretty straightforward. It works just like a Q. You can have negative or positive Q. Next, we have the wah level, which determines how loud our actual wah effect is. We can turn that up or down if we want to hear that more drastically. Next, we also have this auto gain button here, which when using the auto wah effect, sometimes the dynamics get thrown off of a sound of a audio signal because of how the auto wah effect works. And what this auto gain button is, it just kind of compensates and makes sure that the overall volume still is relatively the same. Nothing is super loud and super quiet. It has a nice even dynamic range. Next, we have, speaking of range, we have this range right here, which determines the auto wah's effect range, which we can, drag these sliders up and down to determine where it starts and ends. And then we can also determine where the starting point of that effect is by dragging this. The lowest point is right here, the highest point is up here, and we can determine the starting point with this knob right here. So pretty straightforward with that. Next, we have depth, which this just determines the depth of the actual auto wah effect. If it's at 0, then there's no depth to it. It's completely off. Next, we have attack and release. This just determines how slow or how fast the auto wah kind of actually goes through this entire range. How long it takes to get from here to this top one depends on the attack, and how long it gets from the top to the bottom depends on the release. So that's about it for the auto wah. It's pretty simple actually, especially compared to some of those last few filter effects we've covered. But moving on to the compressor of this effect of the fuzz wah, we have just a simple compressor we can turn off with the power button, or on or off with the power button, of course. And we just simply set the ratio of the compressor using this knob. Very straightforward. You should be familiar with this at this point. Next, we have the fuzz distortion that we can turn on or off again. We just determine the gain of our distortion. We can turn it up, using this knob. And then we also can change the tone of the distortion using this bottom knob here. All pretty straightforward. This effect is definitely, one of the more simpler filter effects. But let's just listen to what our sound sounds like without this fuzz wah effect, and then with.
Get up, get up, get up, get up, get up, get up. Oh.
Okay, now with our auto wah effect, I'm not going to use the compressor or the fuzz distortion. Those are pretty straightforward. We're going to mainly be focusing on the auto wah. So let's just listen to what this sounds like now.
Get up, get up, get up, get up, get up, get up. Oh.
So a pretty cool effect, with the fuzz wah that you get. Very fun to use. That is another one of my favorite filter effects to use. Next, we are going to be covering the spectral gate effect. So the spectral gate, effect is very interesting. It's very unique and can be used for some creative sound design purposes. But essentially what it does is it separates the signal, the incoming signal, into two separate frequency ranges dependent on a center frequency that you pick. So getting right into it, first we have this threshold. This threshold determines, everything that exceeds this threshold is going to be processed by the spectral gate. Then we also have some modulation controls, for some modulation later. Modulation, using an LFO, this just determines the speed of the LFO, and then this determines the percentage of modulation that's occurring to the center frequency, and then this is the amount of modulation that's occurring to the bandwidth. So jumping right into this next part here, we can determine our center frequency using this knob here, and you can see a visual representation of this white line that's moving around as I'm adjusting. And then we also have this bandwidth parameter, which we can adjust how wide our band is that we want to be affecting. So this is where a lot of it comes in, just adjusting your center frequency and your bandwidth. Next, moving over to this area, we get two sliders and two knobs. We get this low level slider and this high level slider, which they both do the same thing. It's just dependent on what side of the bandwidth it's happening on. So beneath the bandwidth, the low level will increase, or it will mix in the original signal into our affected signal, and it'll determine the loudness of that by how we set it. And then same thing for the high level, except it's affecting everything above the bandwidth. So it's adding back in some of our unprocessed signal above the bandwidth, depending on how we set that. The super energy and the sub energy knobs control the level of our frequencies above and below the threshold. So that's what these two do. We can adjust those just like that. And then next we have this gain knob if we need to boost our entire signal or turn down our entire signal. So I'm going to use the super modulation preset so we can hear what, some effects that we can get with this spectral gate. But first, let's listen to it without the spectral gate on.
Get up, get up, get up, get up, get up, get up. Oh.
Now the audio clip with the spectral gate on.
Get up, get up, get up, get up, get up. Oh.
So as you could hear, there's a lot of modulation happening there because of the sliders that they've set here. And it's a very small range that they're affecting. So you can do some very cool stuff. This is just one example. Go through some of these presets. Try to familiarize yourself with this effect. It's a very unique filter effect, definitely. But yeah, I hope you enjoyed this video. That about wraps up the filter effects that are included in Logic. Again, my name is William. Thank you for watching.